Hi guys, welcome to another tutorial of MySQL database administration. Today we will be talking about the high availability solution, basic high availability solution in MySQL. I know you guys have been waiting for this, and so today I will talk about how the replication, what is replication, and what is the architecture, how the replication is happening, and we will talk about some good features which can enhance our replication, and some performance or how we can talk about multi-threading and all that. So today it will be most theoretical part, and in the next tutorial I will be teaching you guys how we can set up master slave or master replica using a binary log position or Gtid based solutions. And I know you guys have been waiting for this for so long, and if you guys like my videos and like my tutorials, so please like, share, subscribe to the channel and support, which give me which help me teaching you guys more and more and coming up with more ideas. So enough talking, let's start with the replication. What is replication? Okay, so what is replication? What MySQL replication does, that it's enable data from help you to replicate data from one server to another server. So it's very easy, and it's very easy to do the setup. It helps what it helps in if you want to shift your read workload or your backup workload to another server, then what you can do is that you can do your reads or the backup from another server. So in case your application is connected to this topology from the master slave replica, then what you can do is that you can add a load balancer in proxy SQL, and then you can, based on split queries, what you can do is that you can go for the reads from the slave and the writes on the master. So this can help you shifting the workload from your master, from your which is your more critical database for read and writing as well. So you can shift half of your workload to another server. So this is how it's very helpful. We have two types of replication: basic replication, which was asynchronous, and semi-synchronous. Okay. And you can mix both of them. What is now asynchronous? Asynchronous is the very simple the very simple replication method. What is it? That the master writes events to its binary log, okay, and then the slave requests them in case when they are ready. So what I'm saying, that the slave requests them. So the master is not telling the slave that you need to do this. It's the slave who is responsible from taking the binary log events from the master, and is saying that I haven't executed these events, the slave says that I haven't executed these events on my database and I need to. So the slave will go and check them. So in this means that this is one way. So it's synchronous. The master does not acknowledge that the slave have these events on its database or relay log. So it's one way. So master does not wait for the slave. Okay, the slave determines how much you read and from which point the binary log I have read. And slave can be behind from the master in case of copying the binary log or applying the binary log to the database using the SQL thread. So this is how asynchronous replication. It has the drawbacks, obviously, because it's only one way. There is no acknowledgement between the master and the slave. So in case the slave, in case the master crashes, and God forbid if there is any lag due to some IO performance on the slave, or any applied SQL thread is not working, or IO thread is not fast enough, if there is any high latency inside your network, in case the master crashes, and obviously if you have the 1 or 2 seconds of lag, then the committed transaction might not be shifted to your slave. And in future, if you want to promote your slave to a master, then obviously you will be missing some transactions. So but the good thing is that it provides lower latency on the master side. So it doesn't matter how many replica you want to have, so it does not affect that much your master server. So this was about asynchronous, and we have the semi-synchronous, where the MySQL master server does not confirm transaction to the client until and unless at least one of the replica have copied the transaction from bin log of the master to their relay logs or to the disk as well. So what is that you require? Obviously you need some extra steps. You need to enable your semi-synchronous plugins, and that are required to be installed, and so this is how you can do it. And semi-synchronous seems to be good and practical solution for many cases, like where availability and data no loss is required, and in case you want to have a master backup server, like if you want I need the same replica and which doesn't have like zero data loss, and I want to back up from that server, then in this case you can have this semi-synchronous. I've seen like people do go for the semi-synchronous for their backup services, backup the server, and that's good to have that. And with that you can also have asynchronous replica as well. Like you have a master server, the backup server is like a semi-synchronous replication, and then you have 2 or 3 slaves or replica which are like asynchronous. So you have asynchronous as well and semi-synchronous as well, so you can have mix of them, and that's good to have. So but yes, obviously this have the performance impact because you have an additional round trip going back and through, like to confirm that yes, both have the same data. So that was about what is asynchronous replication and semi-synchronous replication. Then we have different topologies, like the people or industries is using these days. People are going beyond these days, but this is the simple things like which people are following. The basic one is the master slave, and more or less most of the things, this is like the basic replication architectures, where we have a master server here on the left side, and here we have the slave server. You can see that the replica, nowadays it's replica, the slave is like deprecated, so we should not use slave anymore. So what is that? Had the replica connect to the master, and then the IO thread asks for the data from the master, and there is a thread which is called bring log dump thread, and it sends the content to the IO thread, and then IO thread brings the data to the there is a file, it's called relay log on the slave, and the IO thread will store the data inside the relay log, and from the relay log we have the SQL thread which will apply the data on the database itself. And in case if we have log slave update variable on, then which is on by default, then that MySQL will also, the slave MySQL database will also write those all the transaction to the binary log of the slave as well. So what is bin log dump thread? So like if this is the under architecture, like this is a MySQL database. What is this? That it writes all the data to the MySQL binary log, okay, and then this is the IO thread, okay. The IO thread comes here to the binary log, and this binary log dump thread tells the IO thread it provides the data which is asked by the slave, and the slave insert the data into the relay log. So then relay log, the SQL threads comes to the relay log, and then they store the data into the MySQL database. And then in case we have this variable, it's called log slave updates, then it's also store the data into your inside your the database as well. So what is bin log dump variable? It's here. If you go to the master and you go for the show slave status, then you will see that bin log dump is a Gtid base. So this is the command. So it's dumping the Gtid transaction. In case if it was a different, it would like bin log dump bin log. So that's how this is the thread which is responsible for giving the data to the IO thread. Okay. So next we have, this was a simple master slave, and you can also have one master and different slave, like different replicas, okay. So you can attach different replica, just like I have here, like I have one master, this is my master, okay, and this is my another replica, this one, another replica. I don't go with the this is master, because what I have done is that I did the failover, that's why because my replica 1 is now the master, and the master itself is the new replica, and then we have replica 2, so we can have multiple replicas as well. Then we have master with relay logs, like relay slave, let's say inheritance, you can say. So we have one replica, and then from one replica we have three more slaves. So master to one replica, and then that replica can also you can also create more replica from that, but the intermediate slave or the replica must have binary log enabled, because the rest of the replica will ask from that binary log. So this should have log slave update on. Okay, then we have also have master and master, which is not likely the most. I personally do not recommend this, because this have a lot of things which need to be catered on. But you can also go with that, like you can write to both of the server and they will be in sync. And you need to take care of the auto increment offset, so one of them is like starting from 1, the other should be starting from 2, and auto increment should be like 1. So if this is 1 and this started from 2, and the next will be is 3, then it will be 2, and if it's 3, then it will be 4. So 3 and like that. So one should start, so it should be different. So you need to come up with a variable offset that in both server every time increment goes, so the both of the numbers should be different. So I do have a blog on this one, the master and both of the master. You can see the SQL replication. I will share the blog as well where I have done this, but I do not recommend that you should go for the InnoDB cluster or MySQL group replication or any Percona extra cluster or Galera cluster as well. So those are the best things you can do. Okay, the thing which I was talking about previously, you have a semi-synchronous replication between your backup master. This is a redundant master, which is obviously both of them will be redundant and they will be in sync, and you can also have different replicas as well. So you can take the backup from here and the reads from here, and master will be used for only writing or maybe select for update and all that. So this is one of the best topology people uses, and you can also have multiple masters and creating one replica from as well. So this is another topology people are using. For that your relay log should not be stored in the file, it should be on a table, and relay log index should also be in the table. So this is the things you need to do. I'm not going into how we can do this, I'm not going into details, but it's just I'm showing you the different topologies, in case you have any requirements, so you have the idea that yes, these are the topologies which are supported. Okay, so what is Gtid? I've told you that how the binary logs happens, this thing binary, and then we also have Gtid. What is Gtid? It's the global transaction identifier, which was introduced in MySQL 5.6. And Gtid is a combination of your server UID and the transaction ID. So it's a unique identifier between your source server, which is a master, and also it's uniquely identified on your replica. So this is very good thing, and instead of your binary log position, MySQL slave or the slave, all you need to know is your what is your global ID transaction. So it's the synchronization is done based on the GTIDs, not on the binary log position, and it's very easy because let me show you why you need to have GTID identifiers enabled in your MySQL replication, and why you should go with always GTID enabled. Okay, what happened before MySQL 5.5, that in case if you want to resume a broken replication setup, which requires you to determine the last binary log position and file as well, so which are obviously existing on nodes of if binary logging is enabled, it's different. So if your MySQL master fails, replication breaks, and the slave will need to switch to another master. So if you are going for that, so if you want to promote to the most updated slave node, okay, obviously you need a master which is the most updated one. So what you need to do is that you need to check that which is my most updated, which slave have the most updated log file and the log position. So once that is done, then you will have to point your other slaves to the new master, and you have to tell them that okay, these are the transaction, these are the events, these are the position, till this position you have applied, and now I need to I have identified, which is I have done manually, and now you have to tell the slaves also the file, the log file and the position, that now you need to start the replication from this position. So this is like a huge hectic, because the slave need to be told that this is your log file and this is your position, from this you need to start your replication onward. Okay, and the other thing is that now you have this your new master elected. You have elected based on your most updated log file and position, and then you take the backup of that and you create new slaves from that, and obviously it's going to be time consuming, and like rebuilding or syncing, this is two different things which is time consuming and it's not practical in your production environment. So that's the problem we have in 5.5. So how this Gtid solve the problem? So replication works in such a way that all the nodes will generate different binary logs. That's the thing, and the binary log events are the same and in the same order, but bin log files offset may vary. So the bin log files can be different. Okay, events are the same, obviously, like so events are always the same, but binary log files can be different. So with Gtid, what happens is the slave can see a unique transaction coming from the several masters. Okay, so if it can be several, means it can be multiple or single or any different. So this can be easily mapped to the slave, like, because it's uniquely identified, and it's telling that okay, these are the transactions I have retrieved from the master, and these are the transactions I have executed. So all you need to know that this is the Gtid transaction, like this is the unique server ID. From this server I have executed or I have retrieved till this position, like 4 is the transaction ID. Okay, so if I told you here this is a server ID and this is a transaction ID. Okay, so that's how it's work. So there is no need now required for which is the binary log file and which is my position. So all you need to know about is the Gtid executed transaction. So, and MySQL knows which transaction I have executed, because it stores in the metadata in the MySQL replication tables, and it knows that which next transaction I need to execute. All you need to know, so you don't need to know anything more about the binary logs, and because it's all now about Gtids. Then we have multi-thread slave as well. Till 5.6, what it does, that it allows you to replicate events in parallels as long as the data is spread across several databases. So, and this feature is named as a multi-threaded slaves, or it's called like logical clocks, and it can be enabled by slave parallel workers to grade A, which is greater than 1, or like how many workers do you want to enable. So in 5.7 it can now be used for any workload, including intra-schema, and like then we have its MySQL 5.8. Sorry, MySQL 8. It comes at it's called write sets. I'm not going into multi-threads details, but neither I'm talking about logical clocks and write sets. I'm just talking about how many topologies you can have. Then we have crash safe as well. What does the crash save means? That in case your OS crash, you can recover the slave and continue replication without restoring your MySQL database onto the slave. So to make it crash safe, how this work? You need to have an NuDB storage engine only. It is only supporting that, and if you are using 5.6, then you need to like set relay log info into a table, and the relay log recovery is equal to 1. I'm not going to crash safe. I will create another different lectures and I will tell you that how we can do. So in case you have these two tables enabled, you don't need to enable the sync bin log into 1 and the sync bin log a transaction flush equal to 1 is not required. Okay, what is these two variables? I recently came across these two variables and I knew it, but what happened is that it makes sure that every transaction is written to the disk, and that it can survive server crash. Okay, so InnoDB flush log at transaction commits, but it's just that it have to make sure that every transaction is written to the disk, and so in case if the crash happens, so it can survive. So yes, it requires once this is enabled, when it's one, then this keeping making sure this thing happens, it requires high IO or IOPS, and it's it will obviously make your slave very slow. Okay, and then in case you have a binary log is used for the replication, then sync bin log, if it's set to 1, what it does that it makes sure that every transaction written to the binary log matches the one executed in the storage engine. Okay, so the real log info and the real log transaction and the storage engine transaction should be the same. So this is very IO consuming, and recently I examined a server which had this issue, which has the master and the slave, and it was lagging behind. So the lag was increasing and increasing. So at the end, after excessive working on that and analyzing this replication, everything was fine. There was no network lag, IO thread was moving, SQL thread was moving, but very slow. So what we did is that we enabled this to 0 1, and from 1 to 0, or you can set it to 2 as well, and then sync bin log to 0. Obviously it has some maybe the crash safe is not that, so if you enable them to 0, then it's not a crash safe sleep, but what it does that it can boost your slave. It can be IO, and the threads applier can work very fast, and the lag will go down. So yes, the lag went down, and the lag was not there anymore after this. And in case you don't want to go for the 0 and the 1, then what you can do is that you can enable group commit. What is it that it will not every transaction is written to the disk, every transactions. Okay, so what it does that any other asset compliant databases, our InnoDB engine flushes the redo logs of a transaction before it committed, and InnoDB uses group commit functionality to group multiple such flush requests together to avoid one flush for each commit. So to avoid the one flush for each commit, you can set up the group commit. So it won't be flushing each and every commit, but it will group some multiple transaction, and then after some you tell it the number of how much should be the value of the group commit, then it will do the group commit. So through this you can increase your performance and all that. So this was the basic things which you need to know about the replication. And then for the next onward tutorials, I will be coming up with the black screen, the practical things you want to know, and what are the files you want to require, what are the things you need to do, and how you can check the replication health, and what are the things you need to do. So for this, that's it for now, and in case you have any questions for me, you can ask me in the comments and I will let you know. Thank you so much guys. Please like, share and subscribe my channel. Thank you.